Hello everybody, this is Jeffrey here. I've got a new astrogeology video here for you, and what I'm going to do is cover the possibility of water on Mars, if there's any there, where it went, was there any there, and I have my own theory on the way Mars formed and the history of Mars. And it's not exactly mainstream, but I think once we look at the evidence, we'll see that my theory is right. When Mars first formed 5 billion years ago, it took about 1 billion years for it to settle down to where it had all the water that it had accumulated in its formation had settled into probably oceans, or at least large bodies of water, or a thin layer of water. And early on, it really didn't have an atmosphere. Apparently, it did get an atmosphere after a while, and it had a lot of oxygen, and it had enough oxygen that it turned the rock red and rusted. So it had oxygen, but I think probably what happened is that it got cold before life had a chance to really, get a foothold. Because early when the planet was formed, it had no protection from the sun. So we have UV rays will prevent any basic life forms from starting. Plus, it was probably too cold. I'm not sure if Mars had an ocean when it was cold, because if it did, it was probably frozen. But this is what it would look like if it had an ocean. The problem being, of course, that the distance of Mars from the sun is a lot farther from Earth, which would seem likely that the planet would have been cooler anyway right from the start. Now, Mars is a lot smaller too, and its core was a lot smaller. And it looked like what happened is Mars just cooled off pretty fast, and any water that may have formed like this froze, so that we ended up with a totally frozen planet like this. And once we look at the evidence of this, which is all over the surface of Mars, that show it was covered with ice. Any traces of water erosion came from that ice melting, and that's about it. Now the problem is whatever caused the ice to melt caused this catastrophic climate change that melted the ice, also contributed to the water that melted evaporating into outer space. And I think that probably has a lot to do with the magnetic field of Mars disappearing earlier, or getting very, very weak from the start. And what would have eventually just turned into an ice planet actually just took a bad turn, and all of the ice and water melted and evaporated and was blown off into space. The solar wind is 1 million miles an hour, and it just slowly blew off any atmosphere that had collected. And this takes a long time. It just didn't happen overnight. Probably took millions of years. So the ice continued to melt and evaporate. And once that ice leaves the planet, or that water I should say, or even more specifically the hydrogen, it's not coming back. So it probably had a lot of residual ice, like this, that probably was water. But eventually the water would evaporate, and it doesn't stay in the atmosphere like it does in Earth, where it's a closed system. It just gets dissipated out into space. Now, what this would be probably would be carbon dioxide ice, if anything, because the atmosphere is 96% carbon dioxide. And all of the ice that you see forming is carbon dioxide. So if this was an ocean here of water, which it probably was billions of years, I would say 3.5 billion years ago is probably when some kind of an event happened that started the melting of the ice. I don't think it was just the planet warmed. I don't think it had that much carbon dioxide then. It had oxygen. We know that. So the whole problem is that the water evaporated into space. The only water that's left is residual water that's in pockets underground that hasn't reached the surface, and is probably a pretty good chance that it's frozen. Another thing too is that the planet was probably twice as cold when it was like this. So we were probably talking minus 200-300 degrees average temperature, minus Fahrenheit or centigrade, take your pick. And it's a lot warmer now because it has no magnetic field. The sun's hitting it full blast, and the ice is gone, and it's just slowly but surely drying up, except for pockets. Now they've discovered some pockets of what was probably underground water in the form of ice, but even so, that water there was probably not very pure. It's probably very salty, undrinkable. So basically what we have here is a dead planet with virtually no atmosphere, and any that it does is constantly being blown into space, and I'll show you some proof of that. And when you look at it this way, it looks kind of normal. But if we go to the topographical view, now we see the situation. Most of the most of the higher elevations are at the lower part of the planet. The top part of the planet, here's the North Pole, is all low, and look how smooth it is. There's hardly any craters, which is really strange as compared to here. They're everywhere with huge ones, massive craters. And then we have massive volcanic activity. Most of this high area is all basalt. So we have these huge volcanoes. I don't think the scales, I think it's exaggerated a little bit, but think of the gases that came out of here. You know, the carbon dioxide, carbon monoxide, which it has, argon. There doesn't seem to be that much sulfur in the atmosphere, but probably, there's probably because we have the CO2, so there's reactions going on that keep that from happening. More volcanoes. And these look like they happened possibly during or after most of the ice on the planet melted. There is no magnetic field to speak of. On the bottom there is, and I think it's right around in this area here. There are just pockets of it. The core is no longer molten. So because of that, it will probably never have an atmosphere, and it'll never be livable for humans. The Viking rover is where that white dot is. And I think right here, unrelated to the Viking rover, right in this area here, I think is where there's a huge pocket of permafrost that supposedly has a lot of water in it. And then the Italians have discovered another area down here somewhere. I'm not sure where it was, but it's probably in this area here where there's, they're claiming underground, full-blown lake of liquid water, which I find to be highly unlikely with the temperatures of Mars being minus 100, but then towards, and towards, not towards the core, but I mean, how deep could it be? What kind of water would that be if it's been sitting there for, soaking into the strata around it for millions of years? It'd be hard to believe that it would even still be there. So when we look at Mars today, we see carbon dioxide ice practically everywhere. It's been there for millions of years. Here's a crater. And this carbon dioxide ice buildup is so thick in here, it's actually got a wall over here. It's building up on the mountains. And this is very typical. The temperature here is probably at least minus 100 degrees centigrade in order for carbon dioxide to freeze. If it gets any warmer than that, then this just evaporates. But like I said, the atmosphere is 96% carbon dioxide. So it's easy to see how it could just get so cold that it actually precipitates right out of the air and turns into snow. And I don't even think you need clouds. This could never happen. For one thing, if you even tried to put water into that crater, it would freeze as you were trying to get it in there. But even if you could heat it up and suddenly have water like this, it would freeze right away and then just evaporate straight from ice to air and then be blown off into space. And I will also explain how that happens. Or it would just evaporate before it even turned to ice. And once it evaporates, it's gone. It doesn't go into any kind of an ecosystem or anything. It is possible that Mars looked like this, but it would have to be at least 3 billion years, and this would probably be just before it froze. Relative sizes here. This is just a map of the area that they may have heard the stories, the underground. Now some places are calling it underground lake just to get the copy, but this is really just a big, huge permafrost area that happens to still contain water ice, but it's really deep, up to 640 meters, which is pretty deep for permafrost. But if permafrost is 640 meters deep, that's thousands of feet. And which really doesn't surprise me, considering that the core of the planet is cooling. So the whole planet is just on its way to turning into a total ice ball, except that there's no ice except for the carbon dioxide. So it'll always have that, like Pluto. Pluto's covered with snow, but it's nitrogen ice. Here are the gases. Lots of CO2. This one shows a little bit of oxygen, pretty small amount. Here's some carbon monoxide, and on Earth, that's about how much carbon dioxide we have. Temperature scales. You can pause this and kind of look at it here if you want to, but we have record lows down here. This is in Gale Crater. This isn't all over Mars. So we have average temperatures here, low, or I don't know if those are averages or, yeah, averages over here. And then record lows, minus 197 Fahrenheit. That's pretty darn cold. You won't have any running water. This is just a diagram showing how the periglacial polygons form. These are bulged up here, rocks well up from the middle. In the picture below here, the material gets sucked in here. This doesn't look exactly like those, but it's probably more like these, but it gets sucked up, and then the rocks, and when it melts on a hot day, then the rocks may come loose, and then they roll down to the edges here, and that's how you get these little rock walls. And here's a cutaway view of this thing, the dirt below, and then these rocks, they get sucked up here just from the ground, and then they roll to the top and they fall over to the edge. So when these periglacial pillow shapes dehydrate, they shrink, and then the walls stay. And these walls can be like hundreds of meters high. Here are some of those billowy structures. This means that because they are puffed up, they are retaining moisture right now, and probably it would be carbon dioxide ice mostly, probably a little bit of water ice may still be in there, but you have to remember this is a process where it rotates around from the middle up and then this way, so it rotates around, scooping stuff off as it comes up. So it's like a little miniature glacier in itself. It's just a strange process. And so these are bulged up, meaning that there is still a lot of ice in there. Here's the atmosphere. We've got 100 times the pressure that they have in Mars, or well, that Mars has, and it's practically a vacuum over there. It's so thin. Like I said, the distance, it's a lot farther away, so I would think that the tendency for it to cool, and being so small, it's not like it's really big like Jupiter, where just the force of of its size can generate heat and keep the planet warm or something. It's not going to happen with Mars. The gravity, this affects erosion a little bit too, and the weight of ice and so on. Well, basically that's just what I've just said. Takes 2 years for Mars to go around the sun, 2 Earth years. If it went any faster, it would go into outer space. Any slower, and it would fall to the sun. Mars is only 1/10 the weight of Earth. Temperature scale here, Earth up here, Mars down here. Notice this goes all the way to minus 284, but I think probably when it began to cool, before the ice was gone, I think it was a lot colder. It almost had to be, because the ice formed to start with. And it only seems logical that it would be warmer now because there is no more ice. That's not a big white ball anymore. So it's actually pretty hot for Mars, even though this is insanely cold still. Did I get that right? Yeah. And there's the size. We see the position of Mars down here. It's pretty close to the asteroid belt, which is obviously a blown up planet. When it got blown up, some of that debris probably went in all directions. A lot of it fell towards the sun. A lot of it fell and hit some of the planets, and undoubtedly some of it got blasted into outer space. So you can't really take the mass of what's there and say that that was a planet. It was probably bigger than what's here. And I'd say because of Mars' proximity, it could have taken a beating, and that's what caused everything to go awry. The core is no longer melted, so its dynamo is gone, so there's no magnetic field, no protection from the sun. 6 will fit in there. This is from Solar System Scope. This is all guess. Probably pretty right. I don't know about the core though. I think it's probably a lot smaller. Just some facts over there, distances and things. The part that I wanted was the water part here. It says, strong evidence that Martian atmosphere was once far denser than it was now. Well, I think you can pretty well assume that. And that water once ran freely on the surface. Now they're kind of saying something that probably at one time it may have, but not. I think it ran freely before it froze 3 billion years ago, and then it probably ran a little bit when the ice melted, but it evaporated pretty fast. I'm not sure it even had time to really run forever because it has to have a source, for it to keep running. And like the water was not staying. I don't even think it was raining. I think it just was going right straight up into, just getting blown away by the sun. Mounting evidence that water remains locked away underground. Well, that's true. Important picture here. We got atomic carbon, oxygen, and hydrogen. The wind is coming from the left. The solar wind at 1 million miles per hour. The carbon is trying to hold on to the planet here. Here's oxygen being detected, but you notice the distance away from the planet and its density out here. Then we have hydrogen. And notice the scales down here. Hydrogen, on the other hand, which is what you need to make water, is being blown away. And you can see that the scale here, it's coming out like probably around 3 over here, barely a distance of a quarter of 1. this distance here from there to probably here, yeah, 2 or 3 for sure. So that's the hydrogen. Well, what happens to the hydrogen is when the water gets into the atmosphere, there's no dark side of the moon. When water gets into the atmosphere, it is split by the sunlight. The hydrogen, being super light, goes right to the very top of the atmosphere, and it is the first thing to be blown off by the solar wind. That's why we saw it dispersed out there, out here on the outside edge, way out here, and it is just literally just being blown right off into outer space. And without that hydrogen, that water molecule will never form again. History of water on Mars. Now right about here at the 3.5, I think is where or 3.8, 3.5, I think this is where it froze. And it continued to be frozen until probably maybe 2 billion years. The process started between 3 and 2 billion years. That started the melting and the evaporation of all of the water, ice, and maybe even water. This is if it's terraformed, which will never happen, but that's what it would look like probably. A lot like Earth, of course. Born of the same stuff. This is what Mars looked like. That would be very accurate, I think. This isn't Mars, but it's a planet. I mean, it's a moon, and not of Mars, but it is a moon. That's probably, that could even be water. I'm not even sure. This is the magnetic map. Earth on top looks normal. Mars on below just doesn't have it. The dynamo generates a strong magnetic field only in the south. So it has no defense against the solar wind. Here's an idiotic idea here, is putting this magnetic field generator out here, which has got some big copper parts and lots of pieces that can go wrong, and keeping that in orbit just perfectly between the sun and Mars over here. They have the solar wind conveniently just going way out here. It doesn't go around behind it, or like it would on Earth eventually, I think. And then this will protect the planet, okay? And so then we can go ahead and start living there, terraforming and everything. Of course, if anything happens to this, then, well, it's all over for Mars. Not a very good idea. Here's a really good map of the magnetic fields. You can see here on the right, they're just remnants, as it says down here. Martian dynamo is extinct. Its magnetic fields are fossil remnants of its ancient global magnetic field. Another map showing the magnetic anomalies. Up here at Utopia Planitia, right up in this area up here, I think is where they found H2O rich permafrost right here. The Italians think there's water down here at the bottom. This is where the lake they found, right around here somewhere. That might make some sense too, if there's any liquid molten rock down there that might keep it warm. It might happen. Here's one theory why the whole top of the planet is lower than the bottom half. I'm not sure. I don't know. That might work. It seems like it would leave some kind of a telltale ring around it somehow. But that's one idea. And also there's no craters up there like I showed you. It's all pretty smooth. So it's like it never got hit with any craters really after the ice melted is what I'm thinking, and that the ice was thickest on the top. And that's why there's no craters. Maybe they just never made it through the ice. Pluto, another ice planet, but that's frozen nitrogen ice. But it works the same as carbon dioxide ice and water ice. Pluto again, showing the periglacial polygons. This is all frozen nitrogen. Here's the array of ultraviolet that Mars will get constantly, and it'll be all across the top here. But we're protected. So as long as you're in this range up here, life will not just form on your planet, even if it's warm and you have water, because this will kill anything, any microbes, any microbial, anything small, unless it's at the bottom of the ocean, maybe. So, something to think about. Another handy little chart here. Probably should memorize that. Mars gets all of that. There was just a couple movies here. We don't really need to see those. But here's the sun. Probably should watch that. Very possible that Mars took a hit from the sun. And that would be, would be enough to do it. Mars was in the right place. No protection. All it takes is one big CME, a direct hit. I think Earth may have taken an indirect hit too, a few thousand years back. Topo map showing that the top is very low. It does have this sand buildup though at the very top. Almost looks like more mass at the bottom here. All the elevation is there. Here's the overall map. This is all, most of the permafrost that's active is in these like green and blue zones here. The inactive ones are down here, but they are all over in the orange areas here, the elevated part. Those are just inactive because they're all dried up. This is Gale Crater, and just for reference, the Mars Opportunity rover landed over here somewhere. It traveled all around this edge through here, down through here, coming up the other side here. I don't know if you can see that. And what I would like to say about this crater is this. That crater's been there for at least 3.5 billion years. If ever there was water that formed anywhere, and this is right around the equator, it's not at the poles, So if water formed and it was running water and it was warm enough, these processes take millions of years, and if there was an atmosphere, that meant that it was shielded from UV, then why didn't life form? The only possible explanation is because it got too cold, or it was too cold, or that water was there was only water there before the atmosphere formed. And then after the atmosphere formed, somehow it just froze. It got cold. It went into an ice age, and it never came out of it. And also, shouldn't there be fossils here? If there's ever anywhere that on Mars where they would find fossils, they should have been here. They put the rover in the right place. They went all through here. They found nothing. Nothing except mud rock. Signs of that there used to be water there, but unless we have dates on these rocks, it's hard to place. Another topo map, you think, oh, this looks like water flow, but it's not. You zoom in on this, you see these are flat valleys. This can only be formed from by ice. And probably when the ice melted en masse, obviously the water that was melted followed the paths. But if you look over here, this had to be ice. See how you get these more resistant parts here, and the ice just goes up over it, and then it flows over under. This is a low gravity area too, so it's not going to press down as hard as it would here on Earth, where these would be all ground flat. The ice just went around. It was all from ice. Get this thing to go. There. Well, it took forever. Another nice topo map. Notice the non-activity up here, how smooth it is, almost as if that was covered with something very thick, like probably ice. Water, I think these meteors would have gone right through the water. I think it was probably just heavy, thick ice, and then it just melted. And since it didn't run anywhere, it just melted right from where it was at and evaporated. Another topo map here. Okay. So now we'll take some actual pictures of Mars, and I'll show you that almost everywhere you look, there's signs of glacial activity. Something that I should probably mention too is that the glaciers aren't really made out of ice. They're mostly rock with ice in them, and the ice can be of either water ice or carbon dioxide ice, but enough that it lubricates it and it can move. So we have here a very nice photo, thanks to NASA. And I would like to zoom in on this a little bit and show you some things. First of all, the main glacier came from the upper left down this channel here. You can tell it's wide, and being that this whole entire area, I was wondering when that was going to pop up, is still permafrost. There's still moisture in the ground, and it's frozen. The glacier came through here, spilled out over this entire area. This is all rock glaciers, And this is what you'll find on Mars. You won't find ice glaciers like you do on Earth. Earth glaciers are mostly water ice, and they act accordingly. On Mars, the glaciers are mostly rock. And you can see over here the ends of these. This is not caused by water. Where on here do we see water cut channels? Nowhere. This is the terminal end of this massive rock glacier that has actually dehydrated itself. And obviously the ice is all gone. It's melted, evaporated, and disappeared. So here we have a famous picture. The water, if that's what you want to call it, it's probably too salty to drink, but it weeps out of these layers here, and this is permafrost. This is the top, and this is like you can see the little gullies that the water has formed and dyed. Actually, it's stained, but this changes through the season. So when it gets warm, it does still weep out of there, and I'm surprised that it still does after millions of years. Probably a lot more came out millions of years ago, and it's just so little now that it's hard to even catch these. But this is actual liquid water that almost instantly evaporates. Okay, this is the same thing. It's not as obvious, but it's the same thing happening here. These layers are weeping just a little bit of water. It makes these little channels which change through the seasons. This one doesn't show it very well, but it does happen. So that permafrost can go pretty deep. This is just a big map of some smaller maps that we're going to look at here real quick. This is C, right here in the middle. And you can see that this is a perfect example of a rock glacier. See the high cliffs on the sides here. We have separate events. These could be thousands of years apart, all here. Another one here. And this is probably also dehydrated, but some of these are actually still active enough that they are actually moving. Here we have more scalloped landscape here. No sign of running water though. This is all ice. This had probably a mile thick layer of ice on top of it. Whether it was carbon dioxide, it was probably water. We'll never know. But it just looked like it just evaporated. It didn't even really melt. And it makes sense if your atmosphere is blown off, and it's so prone to evaporation, it'll probably just evaporate straight from the ice. So that's why you don't see just a lot of running water. You think you would see, like Grand Canyons and things, but we don't. This is the area that we were in just now, right here. And you can see when you zoom out here how that looks as far as the scale goes. But this whole entire area is still, was, well, I don't know if it still has water in it, but it was soaked with water when it was covered with ice. It's just taken thousands and millions of years for it to evaporate. And all these channels over here, they're flat bottomed, which means that this was an ice event. Ice did this, not water, not running water. This is solid. This is also carbon dioxide ice mostly. These brown ridges are where it melts around the edges and it exposes the dirt underneath. And these are the same periglacial type processes going on here. It's just that there's not a lot of rocks being brought up to make the walls. We don't find any limestone anywhere in Gale Crater for sure, where we should have found it. If there was ever life there, then there would be limestone, period. But there isn't any. It would look like this. None has been found. These are remnants of more permafrost, the periglacial process, where you get these little domes formed all over the place. These are dried up, dehydrated, and these are the rocks left over in between them. These look like they could still probably shrink a little bit more and get more concave as time goes on. It's probably mostly carbon dioxide ice underground. This is back on Pluto, but we have the same exact processes with nitrogen ice. Doesn't matter if it's carbon dioxide or water ice. Same exact principles. I don't know about these polygonal features, though. I think we get those on Earth, but it's a different form. It's those more like those square ones. More evidence of massive glacier here. This also looks like a terminal moraine of a rock glacier here. This channel looks a little bit like it was made with ice, but it's kind of deeper, so I'm thinking that this may have been cut by running water, but only just for a little while at the last before all the water went away. And this was just probably just the last dribbles of water maybe coming down through that channel, using this channel that was previously laid down or flattened out by ice. Moving on here, we have another absolutely perfect example. Notice the high terminal end walls on this thing as it flows. If I zoom in on that more, you can actually see the periglacial polygons here. They look collapsed, so this is probably dehydrating right now. That's what all those little squares are there. On here they look like squares, but look up here, there. This is more typical here. All permafrost, but it's moving. It's like, yeah, moving permafrost is what it really is, I guess. A creeping permafrost. Put that down to 1. Still working on there. So another zoom in of the permafrost on the rock glacier. Just a shot of some rock of unknown age. I wish I knew the age, but I don't. This could have been laid down before the ice even formed, but that's why it would be nice to have a date on this, but it's very coarsely grained. almost like a fine conglomerate or something. And I would think that would probably be more of an alluvial thing. But if these rocks were billions of years old, that would help. Doesn't seem to be that much metamorphism going on here either. This is how a normal glacier moves. You can see the shapes of the valleys. They're flat. They just move down. The glaciers come from the other valleys and join in. You've got these moraines right here. There's your rock. Just long piles of rock that are deposited there. These glaciers are actually smaller than they were before, thousands of years ago. Another shot. This is on Earth. Mostly ice. These are, rock. These are between the two, like another glacier, and so you can tell the lines separate them. But they're a rock in these. So these are mostly ice. On Mars, it's the other way around. They're mostly rock. More frozen carbon dioxide. The brown areas are just areas that are just have evaporated, exposing the dirt below. And this is not very magnified. I mean, this is looking from way out, and this is really strange, but this is how it is. It's like these little, they're almost the polygon, but it's the same thing. The freezing and the thawing of the carbon dioxide ice over and over and over. Another shot of that, probably a little farther away, but they still got the brown edges on it. That's just where the ice has evaporated and exposed the dirt and rock below. We've already seen this one, showing that it came from the left. This is not water. Here we are on Mars. It's like a really grotesque amount of money being spent on just a few chosen ones. These form from air that's venting out from the ground, and it's spewing out dirt on top of the carbon dioxide ice layer that's on the top. Another map showing a location map where we have already been. Now these are like I say, I can't tell sometimes if those things are collapsed or not. This one looks like it's like they are somewhat collapsed. They're like in mid-range, but the sun's coming from up here, and you can see the silhouette of the sun hitting this rock wall here, so it makes that. So that's why I'm thinking that these are probably collapsing, but they're not completely, sunken, but enough that the walls are starting, these rock walls are starting to show up. But that's a really good example right there of the silhouette of this rock wall. Here's another one, another rock glacier on Mars. But no, not even a sign of running water though. This is very key to what happened on Mars, because when ice melts, water, you get rivers, you get lakes and dams and all kinds of things, blowing, and ravines cut. We don't see that. It's like just all of a sudden the ice just more of it evaporated than melted. More evidence of glaciation, but no running water. Just because you see these things shaped like that, that's just the glaciers following you know, cutting out the land. But it just doesn't have that running water look. Just more of the same here. This is you know, a lot of permafrost up here, and it will weep out the sides of these cliffs here. But this area is already done. It's dried out. There's nothing left to come out there. That's why it looks the way it does. It's just too smooth. There's no gullies. Here's a terminal moraine of another rock glaciation or permafrost glacier. These strips, you can get these and they'll magnify. You know, you can just go in and go in forever. And these are free. You can get them over at the high-rise site. And you can look at pictures of Mars all day long. Still no sign of water. These aren't deep enough. They're too smooth. And okay, here's that same one we already saw. But when you zoom in, look how round it is. I know it's filled in with sand, but you know, if this was water coming all, you should see little, you know, tributaries and things, and just don't see them. This looks like a deposit of an ancient rock glacier or permafrost here that's dried up. Here we go again. The soil all around this whole area was probably soaked pretty good when the ice evaporated, so a lot of the water was retained underground because it wasn't subject to the sun or the atmosphere at all. So it was locked under there, which made this, now that there was no ice holding all this down, the weight of the ice, this stuff was able to slump down like this. And that also has a pretty, you know, the telltale end of it here, the way it slopes down, very steep. Okay, more evidence. Here's another crater, and notice the crater itself. Whatever hit, this didn't hit solid ground. This hit something else, because that ejecta just looks more like it, you know, like it was pretty thick permafrost or whatever when this thing hit. And then we have another glacier inside of the crater with the same telltale walls on it. This material is flowing from over here down into this lower part of the crater. This is all permafrost in here. All over, everywhere, actually. This is a terminal moraine of a glacier. I think I saw that on another channel and they clipped out part of it here. It went like that and then called it a flying saucer. This is a terminal moraine on another Martian glacier. And it's actually receded. The moisture or the ice is already evaporated and gone. This was probably hundreds of meters thick when it was here. And then we have that same hummocky polygonal texture there, meaning that's permafrost also. This is the Grand Canyon in the Great Gale Crater. And it's the same thing. It's not really a deep cut valley, it's wide. So a glacier flowed through here down into the crater from the south. This demonstrates the permafrost layer being blue here. I'm not sure. I think this, the caption that I read for this said that it wasn't really that color, but this would be the water. The blue would be the H2O weeping out of here, and it's in this layer. This layer down here doesn't really have any in it, and it's got that blocky look to it, like it's just drying up. Now here's one. Now these do look collapsed. This is also permafrost, but this is dry permafrost area. These are collapsed, and the walls are quite prominent here. They stick up pretty high. There's probably zero moisture here anymore. It's all gone. It's evaporated. Now I looked at the same one before, and I thought that these were actually sticking up, but these are actually, that the middles were bulged up. They're not. These are concave. They're collapsed because they've shrunk. All the ice is gone, and then this is just a sand dune moving in over here. And this is actually from one of my earlier videos on this. This is fossil-rich limestone. I don't think you'll ever find anything like that on Mars, but that's what they should have found if they're trying to say that there were, oceans and warm, a lot warmer with oceans. You just can't have that with an atmosphere and not have life form. It just seems to happen spontaneously under those conditions. Another glacier. This one is out of my, there it is. Oh, right where that little arrow is, there's and you can't see it. Yeah, it changes. This is like from one year to the next, and so this is constantly changing. This is mostly carbon dioxide ice again. Another a glacier type flow, it looks like here. Look at that, just unbelievable. This is the parachute on the Opportunity rover when it landed. Another shot, the stained sand here. The moisture is weeping out the side here. North Pole, sand dunes, showing almost the rotation of the planet here. Those are carbon dioxide clouds on Mars. Ice spiders, that's the air venting from inside, brings the dust up with it, settles. Just another picture, more polygons, permafrost. Curiosity rover inside the crater, mostly mudstone, little sandstones, other deposits from the wind, but no fossils. More polygons. It's all permafrost. This is how they change. See the change of shapes here. So it's a constantly ongoing process with the carbon dioxide ice. More dried up polygons. Really good picture of the walls formed between the polygons. Totally dry, all the water's gone, all the ice is gone. There isn't even carbon dioxide ice here. But you can see how tall these things are. They are really tall. more obvious evidence of this whole area just being covered with thick ice. Don't know if I went over the scoop marks, but you get these scoop marks out along the edge, and this is where the glaciers just scoop out the dirt, and then it's deposited down here. Here is, I probably should bring this one up. Is this the one that's... But you can see the moisture's coming out, staining down here. So yes, there is moisture on Mars. Here's an animated one that shows it pretty good. And there's the dates down on the right there. So this was March, April, May, March, April, May. So it's quite a lot still. You would think it would be dried up completely by now. This is on Earth, and this is what water does when it cuts canyons. There are no U-shaped valleys here. They're V-shaped, they're sharp. You can see that the water has eroded these mountains down, and that this is a totally different looking process. If there were the same kind of water on Mars, it would look just like this. But there's nowhere on Mars that looks like this at all. Another animated shot from a different angle there. Massive glacier. Here's where it starts, right here, and the material just slumps out here. It just spills out. And it looks like there's more stuff here than there should be, but you know, it's just an ongoing. I don't know how long it took for this to happen either. I mean, did that take 1,000,000 years, or was it 1,000? Who knows? I think this is on Earth, but it shows we have the same type of thing here, but only with ice. Well, I think that's on Earth. It could be Mars, but I kind of doubt it. I think that's Antarctica. More evidence of no water, but glacier and ice action. No water cut rivers, ravines anywhere. Maybe some small ones. You know, I never said there wasn't never any running water. There had to be before the ice formed, and there had to be when the ice melted. But I think that it's just so hard to tell just how much evaporated and how much water really ran before it evaporated. But anyway, here's about the last photo I have here, and this whole area here has the look of being possibly a shallow sea, except that it looks like a glacier came through here, but not necessarily that they were flowing here. I think this area was probably just a thick layer of ice, and This crater has the look of something that hit in some kind of a, fluid, like almost like mud. And if this was a shallow sea, and again, we don't know how old that is, I don't. If this was a sea, then this could have been like a mud flow here. And this has the same look to it. Usually, if it hits in dirt or just plain rock, you get a radiating kind of a star-shaped patterns and stuff being thrown out. This looks like it just hit in mud, got thrown up in the air a little bit, and then came down as a almost like a fluid. And this looks like something flowed around it, but it wasn't water. Water would cut ravines, and there'd be all kinds of lines all over the place. This is like an ice sheet. An ice sheet came through here. Looks like it came from up here, this way, came down, hit right along here, and made those marks as the ice flowed this way. It was like a huge ice sheet. Or maybe it was a huge carbon dioxide sheet. This is a kind of a cool crater because it shows possibly some sulfates or something in that one. But look at that crater. That looks like it hit in the mud. It flew it up in the air and then splat, came down. So there's a lot to tell from this photo here. Now, whether that was ice when this hit, maybe it was an ice sheet and it hit an ice sheet and did this, which would make sense. It would throw all of this material, it would be thrown up on top of the ice sheet, right? Then when the ice melted, of course, this would just fall straight down. And that's where it ended up. And over here, the same thing. We see these striations here, right here. So something slid across here. That was ice. And we have another crater, the same situation here. Now this one does have some, see these lines? This one does have a little bit of a radial pattern on it. So this is a pretty cool picture. There's just so much going on here. And here again, no signs of water here, especially when we have, intersecting lines like this. Hard to say what those are. Almost looks like the land itself is like huge, giant mud cracks. And then there's this crater. That looks like it landed in something like water, or maybe it was just really moist land. But that is the strangest crater I think I've ever seen. It's just so flat, and it's just got this little ridge on it, and that's it. And it's got the rings in here. So something hit. But was this a shallow ocean maybe? Just really shallow? And when did this happen? Are we looking at a billions-year-old crater, and this just filled in with some kind of sediment, or maybe the ice did that? Anyway, pretty cool. So there you have my snow globe hypothesis, my version of it, which is basically shortly after the planet formed and the water coalesced, there was no atmosphere, but it was warm enough that if it did have atmosphere, then life probably could have formed. But I think the cooling process started pretty soon, and it stayed frozen, and it may have gone through an incredible heat wave when most of the ice melted, and this would be water ice, and as the magnetic fields just disappeared, anything that evaporated was just blown right off the planet. So it probably went through a hot stage where so much of it was just evaporated. It didn't even have a chance to melt, it looks like, or you'd see a lot more water. I think that the entire top of the planet was probably where most of the water was, the water ice. And it was very thick, and it was probably the whole top of the planet was just covered thick with this ice, and it just squashed it down so that when it and it also shielded it from meteor impacts, asteroids and stuff, because when we look here we don't see any impacts. How could that be? Unless the ice was just really super thick. And when the ice evaporated, this is what was left. Not really, hardly any craters, but down here there was probably just a lot less ice down on this end. Probably maybe because of all the volcanism, I don't know. But there's a pretty big impact right there. And so if that was real thick ice, I don't know. You could almost, look at it, you can almost see the ejecta right from here. That must have been something. So is that possible then, that all the ice was just caked up all on the top of the planet? It was almost like it was just off balance even. That's the only reason that I can think why we wouldn't see craters all over the place here, and that why it's depressed. It's just the sheer weight of the ice could have done that. I don't really believe the impact thing. I think that it would have destroyed this planet. And it's not perfectly round. There's no round, crater edge around the top. So it didn't get hit by anything. And this is all just sand buildup that's just blown off of the plains here, So when we look at the planet in a new light, a lot of things start making sense. Like, why aren't there civilizations there? Why wasn't there life? Why aren't there no plants? There's nothing there. So I hope that gives you a little insight on what's going on Mars there. I try to do this as short a video as I can, but there's just so much stuff you got to leave out. But I think I pretty well made my point, though. And I didn't pick and choose any of those pictures. I can't find any real good evidence of running water for any appreciable time, at least. So any running water that there was probably just temporary. That's why I think that when the ice did start melting, it may have had some kind of a heat wave. Maybe the planet was enshrouded in some kind of a cloud or something, and it did heat it up enough that it melted everything, and then the atmosphere just slowly disappeared over the millions of years. So that's my story, and I'm sticking to it. So I hope you enjoyed the video, and stay tuned because I'm working on my sea level video. That should be quite spectacular. Have a good day.